Start with the mouth of a Komodo dragon, Varanus komodoensis, the largest living lizard. For decades, scientists gave that mouth the wrong murder weapon. The accepted explanation blamed decay. Bits of meat supposedly rotted between the teeth, feeding dangerous bacteria. Once the dragon bit, escape only delayed the outcome. Infection would spread, sepsis would follow, and the victim could die days later without another attack. The story was neat, memorable, and repeated everywhere. Zoos taught it. Documentaries carried it into living rooms. Biology textbooks turned it into settled fact. There was just one problem. The bite had been hiding a different weapon. Brian Fry, a venom researcher at the University of Melbourne, put it bluntly in 2009. The bacteria story was a scientific fairy tale. His team examined a Komodo dragon with medical imaging, a basic test missing from 3 decades of confident repetition. Inside the lower jaw, they found well-developed venom glands. The secretion interferes with clotting, lowers blood pressure, and helps drive bitten prey into shock. Fry's research also reported compounds comparable in potency to components of venom from the inland taipan, Oxyuranus microlepidotus, the world's most venomous snake. The microbes in a dragon's mouth were never imaginary. They had simply been cast as the killer. The scan shifted the focus to venom, blood loss, and the devastating physical damage of the bite itself. That makes the Komodo dragon the largest living venomous lizard, a status scientists recognized only after examining the anatomy directly. A full-grown animal can reach 3 meters and 100 kilograms. Over a short burst, it can reach about 20 kilometers per hour. It can also bring down prey many times heavier than itself, combining bite trauma, blood loss, and venom, rather than relying on a filthy mouth. Yet modern science arrived remarkably late. Until 1910, the wider world had no confirmed record of the species. On Flores, Dutch colonial lieutenant Jacques Karel-Henri van Steyn van Hensbroek kept hearing reports from sailors and pearl divers. They spoke of a land crocodile on nearby Komodo, big enough to kill a water buffalo. He sailed to investigate, shot an animal about 2.2 meters long, then sent its skin and a photograph to Peter Owens, director of the Zoological Museum in Buitenzorg, Java. Owens saw what the nickname had concealed. It was no crocodile. Owens was looking at an undescribed monitor lizard, and the largest living lizard science had documented. He published the first formal description in 1912. Through the whole recorded span of civilization before then, a predator longer than a grown man had survived, sometimes only about 9 meters from the nearest fishing village, while remaining effectively unknown beyond its few islands. Outsiders had simply had little reason to search there. That isolation still defines the species. Almost nobody beyond eastern Indonesia will ever meet a wild Komodo dragon, and geography is a major reason any survive. Fewer than 4,000 remain. Their range is concentrated on Komodo, Rinca, Flores, and several smaller islands within what is now Komodo National Park. For an apex predator, that territory is exceptionally small. The dragon escaped scientific notice because its world was tiny and remote. The same narrow world now protects it, but also leaves the entire species confined to a few scraps of land. People on these islands know the dragons better than anyone. Knowledge reduces risk. It cannot erase it. One Saturday in 2007, an 8-year-old boy on Komodo Island stepped behind a bush to relieve himself. His uncle was fishing nearby. Seconds later, he heard screams. A dragon had clamped onto the child's waist and was whipping him from side to side. It was the same tearing motion used on carcasses too large to swallow whole. The uncle pelted the lizard with rocks until it released the boy and disappeared into the brush. The wounds had already done catastrophic damage. Roughly 30 minutes later, the child died from massive blood loss. Park officials then confirmed another grim fact. This was the first recorded fatal attack by a Komodo dragon in 33 years. An entire generation on the island had grown up without seeing one kill a person. Their belief that dragons no longer killed people was understandable. It was also wrong. Then, in March of 2009, 31-year-old fruit picker Muhammad Anwar climbed a sugar apple tree on Komodo Island. He fell. 2 dragons were beneath the tree. When a neighbor reached him, bites covered his hands, torso, legs, and neck, and he was bleeding heavily. Anwar died soon afterward at a clinic on a nearby island. At that point, Anwar's death was the second confirmed fatal attack in little more than 2 years, following 33 years without one. So why are deaths still rare? The answer is exposure, not restraint. Fewer than 4,000 dragons occupy islands that most people will never visit. Around 1,700 residents of Komodo Island share that habitat, carrying generations of practical knowledge about when and how to stay away. Visitors receive another layer of protection. They move through the park with guides, who carry long, forked sticks made to push back a charging dragon. Those precautions do not make the lizard harmless. They keep people from giving it many opportunities. Beyond that tightly managed overlap, wild dragons and people almost never meet. Distance is the real safety barrier. The rarity of attacks says nothing about what the animal can do. It reflects where the animal lives. And geography does not stay fixed. Komodo National Park now receives well over 100,000 visitors each year. The number continues to rise as these islands become a regular stop on Indonesian travel routes. Every season, more people pass through dragon habitat than during almost any earlier period in the species' recorded history. Meanwhile, rising seas threaten to reduce the low grasslands that support the deer and buffalo dragons depend on. If those prey populations are squeezed, food-stressed dragons could move closer to trails and camps used by tourists. That outcome is not certain. More visitors do not automatically mean more attacks, and neither does habitat loss. But the two pressures are increasing together. Human traffic is increasing within the dragon's remaining range, while pressure on that range is growing. The separation that kept encounters rare for decades may not remain as wide. When that separation fails, venom is only part of the danger. The bite belongs to a hunting system built around slashing wounds and blood loss. A Komodo dragon does not always need to overpower large prey immediately. If the wounded animal escapes, the dragon can follow it for hours, sometimes days. The trail is chemical. The dragon flicks its forked tongue through the air, collecting scent particles and carrying them to the Jacobson's organ in the roof of its mouth. Each tongue tip samples a slightly different position. By comparing the strength of the odor on the left and right, the dragon can steer toward its source, much as 2 ears help locate a sound. With favorable wind, this system can detect a carcass or a bleeding animal from several kilometers away. The wounded prey keeps moving, but clotting is impaired, blood pressure falls, and blood loss mounts. Disorientation and shock can follow. Eventually, the animal may collapse. That is when the distance gained after the first bite stops mattering. The dragon has not abandoned the hunt. It has been reading the trail. An escaped prey animal may still leave a trail. Blood draws other dragons to the scene, and they may track the wounded animal and feed if it collapses. Tracking wounded prey does not require sustained speed. Biochemistry weakens the prey, while a highly sensitive chemical tracking system follows the trail beyond the reach of teeth and claws. Up close, though, speed still matters. In a short burst, a Komodo dragon can reach about 21 kilometers per hour, faster than most people can run across the same distance. It cannot hold that pace. Its normal walk is closer to 3 to 5 kilometers per hour, but it can lunge much faster. Water is not always a barrier either. These lizards swim between islands across the archipelago. If the victim later collapses from a serious wound, the dragon can locate it again. The next number wrecks the usual picture of this predator. Judged only by closing force, its bite is remarkably light.
Brian Fry, who identified the venom glands, later led a modeling study of the Komodo dragon's maximum bite. The estimate peaked at roughly 39 newtons. In the same comparison, a saltwater crocodile of similar size reached about 252 newtons, around 6.5 times as much. A large domestic dog also bites harder. Push the comparison further, and the dragon falls into the same raw force range as a fennec fox, weighing about 1.6 kilograms, small enough to rest in a person's arms. So the danger cannot be explained by jaw pressure alone. That weakness matters only if a predator has to crush its prey. The Komodo dragon cuts instead. Around 60 curved, serrated teeth sink in and slice. Then the neck and body haul backward, dragging those edges through flesh. Beneath the wound, venom adds another layer to the attack. Crushing power is almost beside the point. A single effective slash can be enough. This anatomy makes a modest bite deeply damaging without crocodile force, and the same economy continues after the hunt. When a Komodo dragon reaches a carcass, little of the opportunity is wasted. One successful meal can carry it through a long fast. An adult can swallow as much as 80% of its own body weight in one meal. After that, it may go for weeks, sometimes months before feeding again, thanks to its slow metabolism. This is a body tuned to scarcity. A rare kill has to last. That shortage also drives the grimmest danger in a young dragon's life.
The threat comes from its own species. Cannibalism is estimated to account for 10% of an adult's diet, and smaller, weaker dragons are the main targets. Hatchlings answer by leaving the ground. For their first 2 to 3 years, they live almost entirely in trees. Sharp claws and a long tail carry them through branches as high as 10 meters, beyond the reach of heavy adults below. In that canopy, they hunt insects and geckos and raid bird eggs. Their world bears little resemblance to adult life on the ground, but growth eventually closes the refuge. As their bodies become heavier, climbing stops being practical. Eventually, the young dragons must descend into the same ground-level arena where adults once hunted them. Then the story takes a stranger turn. The venom research changed the scientific story of the Komodo dragon in 2009. A discovery from the middle of that decade challenged a more basic assumption. Reproduction required a male. In 2006, researchers used genetic fingerprinting to confirm that Flora, a female at Chester Zoo in England, had produced viable eggs despite never being housed with a male. Stored sperm was ruled out. The young carried only her genetic contribution, created through the form of asexual reproduction called parthenogenesis, which is rare in vertebrates. Another isolated female at London Zoo had done the same thing months earlier, after more than 2 years without a male. The species' system of sex determination gives this process a peculiar result. Every offspring produced this way is male. In theory, a lone female reaching an empty island could begin a population without a mate. First, she would produce sons. Once they matured, normal breeding with them could continue, and the island would no longer have just one dragon. That route remains theoretical, but the genetics allow it. Eggs first, sons next, then sexual reproduction after they mature. Finding this ability in one of the planet's largest lizards caught researchers off guard. Researchers still do not know how long this reproductive capacity has been present. The dragon's importance extends beyond its own reproduction. Across its islands, it occupies the top of the food web, and every level below feels its presence. Komodo dragons prey on the Timor deer and water buffalo that share their habitat. They remove animals that are sick, old, or simply caught at the wrong moment, reducing the chance that herbivore numbers overwhelm a fragile island ecosystem. Timor deer dominate the adult dragon's diet. Predator and prey have shared these islands long enough for the deer to show measurable changes in behavior. Near trail edges and thick brush, where a hidden dragon is most likely to ambush them, the deer stay especially alert. That vigilance is the prey's answer to a predator that rarely needs a long chase. That alertness is concentrated exactly where an ambush is easiest, beside trails and dense vegetation. It is one visible thread in a much larger balance. If Komodo dragons disappeared, grazing pressure would change. Vegetation and the mix of species would change with it, though the full chain of effects is hard to predict. There is no equivalent predator ready to replace them. On Komodo, Rinca, and Flores, no second apex hunter occupies the same niche. That leaves a highly isolated ecosystem dependent on a role filled by one species alone. The islands are small, and their ecological communities occur almost nowhere else on Earth. Losing the dragon could disrupt the entire system. The risk comes from a simple fact: nothing else performs the same work at the top. Isolation makes that system vulnerable, but it also keeps encounters with people relatively rare. Even park rangers inside Komodo National Park remain at risk. Experience improves their odds. It does not make the animal safe. In one incident, a dragon entered a ranger's sleeping quarters at night. It bit him on the hands and legs. The attack is a blunt reminder that even experienced rangers are vulnerable. This predator is patient, and it exploits an opening when one appears. Knowing its habits may help a person react, but familiarity cannot remove the danger. And that brings the story back to the real reason Komodo dragons deserve such close attention. Their significance is not measured by a long tally of confirmed human deaths. The Komodo dragon, Varanus komodoensis, registers a weaker bite than a house cat. That result should have demolished its reputation as a lethal giant. Instead, it exposed how badly science had misunderstood the animal. For 3 decades, textbooks repeated an explanation for the dragon's deadliest weapon that one researcher later called a fairy tale. Then someone tested it directly. Jaw strength was not the real story. Venom beneath the bite makes that modest force almost beside the point. The surprises keep coming in its reproduction. A female can begin a whole new population without arriving with a male, overturning a rule many people assume applies to every large vertebrate. The young then retreat into the canopy, living out a hidden juvenile phase because adult dragons may eat them. Even the dragon's arrival in science reads like a warning. On an island inhabited by an animal this large and venomous, the outside world had no documentation of it until a colonial lieutenant pursued a rumor in 1910. After all that, the most accurate answer remains deeply unsatisfying. For many questions about the Komodo dragon, part of the answer remains, we do not fully know. That uncertainty is more unsettling than any attack. For decades after its discovery, experts were confidently wrong about its bite. The corrections came piecemeal. A scan, a genetic test, then a skeptical researcher checking the accepted story. On that same handful of islands, other details may still be undiscovered. Venom waited unnoticed until somebody thought to look. Another fact about the dragon may be waiting just as quietly.